everybody. We were just having a few technical difficulties there. It was a bit slow, so I'm glad can you give me a like or say hi if you can see me? Hello, everybody. Welcome to my kitchen. I'm so excited for this week's STEM workshop. Fantastic. Anybody with us? We were having just a couple of technical difficulties, so just like if you can see me and hear me. Hello, everybody. Welcome to STEM Live. Hello, fantastic. I'm so glad that you can join me today in my kitchen, or should I say, my science lab. Yes, it is. And we're going to talk a little bit more about that today. So welcome. Hi, Tabitha and Harrison. Hi, Caleb. Lovely to see you. So glad you could join me today to explore the science of my kitchen. And we're going to be looking today at pancakes. So it's Pancake Day next week. So you'll be able to, while you're making your pancakes, your challenge is to be able to explain to your families all about the science of pancakes. Okay, so we'll just wait for everybody to join us and then we'll get started. In the meantime, for anybody that hasn't joined us before, my name's Lois, Miss Hale, and I work in the Birmingham and wider region for the STEM workshop. And I work alongside Leanne Mee, or Mrs. Mee, who works in Shropshire and the surrounding areas. And we love to come into your schools or to events and do some really fun, exciting STEM activities with you. So as we can't be with you at the moment, we thought we'd come through your computer screen and have some fun exploring STEM. So hi, Jack. Lovely to see you. It's really nice for you to join us today. I hope you're excited. We've got all our ingredients ready. Fantastic. So I'll just talk you through the ingredients. Don't worry if you haven't got them all. You can just listen along and watch along with me. And then afterwards, when you've got all of the ingredients, then you can make your pancakes and explain to all of your families about all the science behind it. So if you have got ingredients for pancakes, I'll just run through them for you to double check. Okay, so we need any vessel. I've got a glass so that you can see inside it, but you can use a normal mixing bowl or a mixing jug to make your pancake mix in. 1 egg, you only need 1. 1 cup of milk and some flour. Okay, that's what you need. I've just realised I've left my flour on top of the cupboard, so you might see me scaling my cupboard in a minute to get down some flour. So what we're going to do today is explore STEM. So everybody shout together, what does STEM stand for? Fantastic. Science, technology, engineering and maths. Well done. So that is STEM, and today you're finding me in my science lab, where I'm going to be exploring chemistry, the chemistry of food, food tech, making food, which is a product. You know, we go out into shops and we buy food. So food is a product. So design and technology is a subject where we learn about how to design and make and produce food items. Today it's pancakes. There are loads of different scientific experiments that you can do in your kitchen. All around me in this room and in your kitchen, this is my science lab, as I've said before. This is where all the science happens in our house. Got my fridge. What does our fridge do? Keeps our food cool, which keeps it fresh. There's science there. Our freezer preserves food. Our microwave and our oven warms up food, which is physics, and it cooks, which is chemistry. There's science everywhere. Any other ideas about where there might be science in our kitchen? Write your answer in the comments box and we'll hear all your ideas. Where is there science that happens in your kitchen? I want to hear all your comments. I know you're out there. Write it in the comments. If I turn my hob on, you can see the flame. That's science. That's a chemical reaction happening there. The gas in my cooker is burning, and that's a chemical reaction. Fantastic. The oven, well done. Good job. The oven. So we're going to get started on making our pancakes. And today, the chemistry that we're going to explore is the chemistry of change. Okay. Now, all materials change, and chemistry is the study of materials. So there are two ways that a material can change. It can change forever, which is a chemical change or a chemical reaction, or it can just change for a short while and then you can get it back. And that's a physical change. So a chemical change is a forever change, it changes forever. And a physical change is it just changes for a little while and then you can get it back exactly as you started. So I'd like you to get your ingredients, and the first thing I'd like you to do is take your egg and break it into your container. Fantastic. And then just beat it a little. Okay. So we've got our egg. Okay. And now we're going to add 1 cup of milk. So if you want to make more pancakes for your whole family, it's a really simple recipe, this one, because it's a 1:1:1 ratio. Ratios are maths, so we're measuring and we're using ratios here. It's our mathematics. So for every 1 egg, you need 1 cup of milk and 1 cup of flour. So it doesn't matter if you don't use a proper baking cup, as long as you use the same cup to measure the milk and the flour, then it's fine. Okay, so add in your milk. I have to do mine carefully because the container I've got is a little bit narrow. There we go. Okay, so I've added my milk. Okay, it's not changed. Okay, we've mixed it together. Now, it is possible, it would be really tricky with the equipment in my kitchen, but if we went to a science lab in a university or in a school and used some specialist equipment, we would actually be able to separate this. It'd be really tricky. We'd need a really good filter, but we'd be able to separate them and get our egg and our milk back again. So we are mixing, and this mixture, it's a physical change. Okay, we can get them back. It's a physical change. And now I'm going to scale my cupboard to get my flour down. Which one is it in? This is the problem with being a bit short. I can't reach the top of my cupboards. There we go, I managed it. So I've got my flour. 1 cup again, so it's a 1:1:1 ratio. And you can practice your ratios when you're making this with your family, because if you want more pancakes, you just have to double everything up. 2 eggs. How many cups of flour? Yes, 2. And how many cups of milk? 2. Good. So for every egg you add a cup of flour and a cup of milk. So here's my mixture now. Now, I'm going to mix it all together. Now, again, this is just a mixture so far. So we'd have to go to a pretty good lab with a pretty good filter, but we'd be able to separate this out. Okay, so now I'm creating my mixture. Now, if at this point you think to yourself, this looks a bit thick, I'm looking at this and I'm thinking this looks a bit thick. So I'm going to add a bit more milk. So when I put my pancake into a hot pan, can anybody tell me what's going to happen? Write in the comments what's going to happen when I add some pancake mix to a hot pan. Write your ideas in the comments. Any ideas? I'll cook it on this one so you can see what's happening. Fantastic, well done. It's going to turn solid. Excellent. So it's going to change. Can you ever get this mix back after we've cooked it and it's gone solid? That's a good science keyword, that is. Well done. Can we ever get this mixture back once it's cooked? No, we can't. Well done. We can't ever get our eggs, flour and milk back again. It's gone forever. It's a pancake forever. So I'm just going to reach behind here and get some oil. Okay. Bit of oil in the pan, not too much. And it's going to heat up. Now, this oil's getting hot and hot and hot and hot and hot. Fantastic. That's right. You didn't think so. Well done. You were right. So you can never get it back again. And that's because what's going to happen is a chemical reaction. And that's why I said to you that my kitchen is my science lab, because this is chemistry in action. I'm creating a chemical reaction here, changing a material, and it's never going to change back. So let's see. The first one's always rubbish, isn't it? So let's give it a go. Just put my fork aside. Oh, it's a bit lumpy. I'll need to whisk that a bit more. Okay. So what you can see happening is it starts off as a liquid, as you said, and then it's heating up. And the heat is giving that pancake mix some energy. And so many chemical reactions in the universe need energy to happen, need a bit of a boost of energy to make the chemical reaction happen. And our pancakes are no exception. So the heat makes the chemicals react with one another. All of those materials that we're adding together, the ingredients, the egg, the flour, the milk, they're all reacting with each other and forming a pancake. And it's completely changed. It's a solid, which means it's a fixed shape and it can't flow anymore. This isn't a fixed shape. I can pour it into various different containers and it will just fill the container. My pancake is now a fixed shape, the pancake shape, and it can't flow anymore. If I tip this pan, it will just fall out in a blob. So, in a pile. I'll just get my spatula. As I said, it's always the first one is never quite so good. While that's cooking, I'm going to carry on whisking. So, have a go at making your pancake and watch that chemical reaction happening. See, as the liquid turns to a solid, that's one sign of a chemical reaction, a change of state. Another sign of a chemical reaction is a change in colour. Is your pancake changing colour? Have a look at it. Might not look it yet. Let's leave it a little bit longer. What do we think? Can you predict? Is your pancake going to change colour? Good. Let's see. Right, I think I'm ready to flip mine. I'm not going to be brave just yet. There's still a bit of oil in this pan. So I'm not going to flip this one, but I might pluck up the courage in a little while to have a go at flipping it. Okay, so I can see now I flipped it. There's a colour change. Has anybody else's pancake changed colour? Mine has. Mine's gone brown. Okay, colour change. Another sign of a chemical reaction. So it's changed state. It's gone from a liquid to a solid, and it's changed colour. That's two signs of a chemical reaction there. Okay, good. I'm just going to grab a plate to put this one on. My children are going to be very happy after this. They'll have a plate full of pancakes. I'll make a couple and then we'll do another little experiment with the chocolate and talk about how the chocolate changes. So we'll just finish off that pancake, grab a plate. I think I need to turn my pan up a bit. Good. So, as I said, while you're making your pancakes, I'll just go over that science again. So, if it's a chemical reaction happening to a material, it changes forever and it can never change back. And you can spot a chemical reaction by looking for a few different things. One, you can look for a colour change, and two, you can look for a change of state. Oh yeah, that's really, I've burnt it a little bit, look, and it's really changed colour. I don't know if you can see that. There we go. So that is a chemical reaction, or sometimes we call it a chemical change. Okay, so that's chemistry in action. Other signs of a chemical reaction, which we can't see here, are bubbles and also a powder. If you mix two liquids together, sometimes if they reacted, it forms like a powder at the bottom. Okay, that's another sign of a chemical reaction. Also, another sign is a change of temperature. Either something getting colder or something getting hotter. Okay, so let's have another go. See if this one's any better. That was our practice one. Good. So again, oh, I put a lot in that one. Good. So watch, now I've got a liquid and it's hit the heat and it's reacting. And all those ingredients are reacting together and it's changing forever. Okay, while that's cooking, I'm going to start another one. I'm just going to pop my kettle on. And in here, in my plastic beaker, I've got some chocolate. Okay, you can hear the kettle going now. I've got some chocolate and I'm going to melt this chocolate. Now, what I want you to do now is predict melting chocolate. Is this going to be a physical change, a change that can go back to how it was in the start? Or do we think it's going to be a chemical reaction? Do we think it's going to change forever when I heat this chocolate up? Now, keep a parent or an adult close by if you're starting to use boiling water to melt chocolate. Another way to melt chocolate is to pop it in the microwave for a few seconds. Okay, good, we've got some answers. I don't think so. Good, no. And there's also a yes. Is it going to be a chemical reaction or a physical change? Let's find out. Have a go. Have a go melting chocolate. You can either pop it in the microwave for a few seconds, or you can put it in a bowl like I am. I've got a bowl there. And I'm just going to put water in the bowl around it that's hot. Okay, let me do it somewhere where you can see. I'll turn that off a minute. Okay, can you see that there? Yes. Okay, so all I'm going to do is put hot water into the bowl and the hot water will heat up the chocolate. Well, we've got heat again, so we might make it react. Is it going to? Just grab a spoon. Fork. Okay. What's going to happen to it? What word? It's quite a scientific word, but you use it in everyday language. You probably use it a lot in your kitchen. Okay. What word can you use to describe what's going to happen to this chocolate now it's getting hot? See, what's going to happen? It's going to, yes, good. It's going to melt. That's a good scientific key word, melt. So the chocolate is going to melt. Now, if I were to put that chocolate back in the fridge again, would it go back solid again? Or would it stay melted as a liquid forever? What do you think? Good, well done. It would melt. I've just seen your answer there. Well done. Yeah, Is it going to stay melted forever? Or could it turn back to solid chocolate again? What do we think? Good, well done. It will go back solid again. Well done. If we put this in the fridge, it will go back solid again. So tell me then, is that a chemical reaction or a physical change? Good, it's a physical change. We have changed the chocolate. Mine started to melt already, as you can see. We've changed the chocolate by adding heat, but it's not changed forever. We can get hard, solid chocolate back again. So that means it's a physical change. So this is the science of my kitchen looking at pancakes. We've created a product, a pancake. We've done that by making a chemical reaction. All those ingredients have reacted together. Chemical reactions happened and it's made that pancake solid and super, super tasty. And then we've heated up the chocolate, but this time it didn't react, it melted. And melting is one example of a physical change. It's not forever, it's only while it's hot. And then if it's cooled down again, it goes back solid again. So we've got an example of a physical change and an example of a chemical reaction, all happening inside your kitchen in your home. Okay, so what your challenge is now is to be able to, on Pancake Day, explain to your family the science of pancakes. Have a go at making pancakes. Have a go at explaining to your family, and then upload any photos or videos of you exploring pancake science. Ask your parents to upload them onto social media and tag us. So on Facebook or Instagram or anything like that, tag us in and we will choose a winner for the best video or picture of you exploring the science of pancakes. Okay, have great fun exploring science in your science lab, and I can't wait to see all of the wonderful creations that you do. Have a go at melting chocolate, have a go at cooking your pancakes and see chemistry in action. Have a great time, lovely to see you all, and I will see you here, same time, same place next week. And stay tuned, keep an eye on social media to see the wonderful challenge that we're going to be giving you next week. Okay. Oh, I'll say next week. Hold it. Wait, it's not next week. Next week's half term. Holiday. Brilliant. So yeah, not next week. It's 2 weeks' time. 2 weeks' time. Same time, same place, 2 o'clock, YouTube Live, 2 weeks' time for our next challenge. Okay, thank you for joining us. Have a wonderful half term and a wonderful time exploring science and STEM. Bye now.